All right, so today what we're going to do is we're going to talk about properties of numbers. And what you might want to do is real quick, you may want to pause the video and write this down, okay? Because we're going to be using this, and this stuff right here is, it's really what we're going over as we go. So you might want to write that down, and we're going to go through it so that whenever I go through it, you're like, oh, okay, I understand what we're talking about. All right, so properties of equality and identity. The expression 4K plus 8K and 12K are called equivalent expressions. They're equivalent because they represent the same number, okay? So if I put 4K and add 8K to it, that gets me 12K. Therefore, they have the equal value. Therefore, they're equivalent expressions. This video is all definitions, so you got to be ready, and so that you understand what we're talking about. Because properties is basically dealing with definition stuff. All right. The properties below allow you to write an equivalent expression for a given expression. So these are properties of equality that they're talking about here. And what you have is your reflexive property, and I'm just going to go through them, try and tell you what they are. Okay. So reflexive property. Any quantity is equal to itself. Well, that makes sense, right? 5 equals 5. 8 equals 8. 100 equals 100. That's what we're talking about with this reflexive property here. 5 equals 5. And it makes perfect sense. It's just a matter of how they write it and what they're calling it. Okay, so, and you're going to use these properties, so make sure you know them. All right. Symmetric property. If one quantity equals the second quantity, then the second quantity equals the first quantity. Okay. So if 8 equals 2 plus 6, then 2 plus 6 must equal 8. And when you think, I mean, all of these are intuitive, right? They make sense. Okay, when you think about them, they make sense. Well, what's 6 plus 2? Well, it's 8. So 8 equals 8 here, right? So 2 plus 6 equals 8. So 8 must equal 2 plus 6. And it's just really all it is. So that's the symmetric. Okay? And they give you the symbol versions and they give you the word versions. Guys, I like the examples because it makes sense whenever I look at it. If you need the word versions, they're up here if you want them. Okay? So transitive. Transitive property. If one quantity, and here's where I'm getting the words, right? If one quantity equals a second quantity and the second quantity equals a third quantity, then the first quantity equals the third quantity. Now this is where I like the symbols on this one. All the others I use the numbers, but on this one I like the symbols, right? Because it really kind of makes it a little bit more clear. If A equals B and B equals C, right? If A equals B and B equals C, then A must equal C. And that makes sense when you think about it, okay? If this is the same as this, and this is the same as this, then this and this are the same, okay? It makes perfect sense, all right? Substitution property, we've already used this a little bit. A quantity may be substituted for its equal in any expression. So kind of like when we say, well, n equals 7, and then we give you 4n, you can take that n equals 7, you can take that 7 and substitute it in for that n. Okay, that's all it is. If n equals 11, then 4n equals 4 times 11. That's what that is. Okay? The substitution we use it all the time. All right. Keep going, and I'm going through these pretty quickly because you can pause this and you can write it down, and I don't want you to spend a lot of time watching this. All right, so additive identity. For any number A, the sum of A and 0 is A. So like 2 plus 0 equals 2. You've seen this identity property before. That's what that is. It's an identity property. So you have identity property of addition, identity property of multiplication. They also call it additive identity. Okay, so 2 plus 0 equals 2. Remember, identity properties are when you get back that same number. All right, you get back the same identity. That's what that is. Additive inverse. A number and its opposite are additive inverses of each other. So I kind of like this. A plus negative A equals 0. Right? So when you add a number and its additive inverse together, you're always gonna get 0. So 3 plus -3 equals 0. 4 minus 4 equals 0 because 4 plus -4 equals 0. Remember your sign rules, that's what that's talking about. All right. We're gonna come down here, I'm not gonna read that. Multiplicative identity, right? Identity property of multiplication, that's what that is. For any number A, the product of A and 1 is A. When you multiply any number times 1, you get back that same number. That's that identity property, okay? Multiplicative property of 0, also known as 0 property. So it depends on who you're talking to and what they're gonna give you. Probably, I'm gonna give you 0 property most of the time, because that's how I remember it. Okay, so when you multiply any number times 0, you get back 0. All right? So the common mistake is to mix up the 0 property and the additive identity property. Be careful with that. All right. Multiplicative inverse or reciprocal. We talked about that in another video also. So multiplicative inverse or reciprocal, when you multiply a number and its multiplicative inverse, you get back 1. That's what it's talking about. And we have it right here, multiplicative inverse, 3/4 times 4/3 equals 1. As in, you have to know these because you're going to use them not only this year, but next year and the year after that. So you got to know them. And most importantly, you need to know how to use them. Okay, you have to know how to use them. All right, so that's multiplicative inverse. All right, so what we're going to do is we got 2 more properties in here we're going to talk about. We're going to talk about, let's go ahead and talk about them because they're really not that hard. And you've seen them before. Commutative property. Remember, commutative is about order, so you get to rearrange things, right? So 4 plus 8 is the same thing as saying 8 plus 4. Or 4 times 8 is the same thing as 8 times 4. These do not work with subtraction or division. It only works with addition or multiplication. Matter of fact, that's true for all of these if I remember correctly. Yeah. All right. Associative property is about grouping. So how you group things together, right? 3 plus 5 in parentheses plus 6 equals the same thing as saying 3 plus 5 plus 6 in parentheses. It's that you can group. You can change your groupings around, right? 3 times 5 in parentheses times 6 equals 3 times 5 times 6 in parentheses. Because it's all multiplication, I can rearrange it. Because it's all addition, I can rearrange it. Okay? Or I can, not rearrange, I can regroup. Sorry, I used the wrong terminology. I can regroup. But the same thing applies up here as far as order. Because it's all addition, I can reorder it. Okay? It's all multiplication, I can reorder it. All right, so now that you've seen all of these, how are we going to be using these things? Okay, well, what we're going to do is we're going to do kind of a proof deal, is what it's called. And that's where you take a problem that has been solved out, or you solve a problem, but you identify each step that you took in order to solve that problem. All right? So we're going to take, and what they've done is they've laid out this, basically a skeleton of how you work the problem. They've already worked it for you, and they're coming in there saying, hey, tell us what property you're going to use, or what property we use, in order to start solving this deal. So what you have to do is you got to look at the original problem and the next step to decide what step did they take in order to get to that next part. All right, well here, they've got 7 times 4 minus 3, parentheses, minus 1 plus 5 times 1/5 equals, and then they say, okay, this right here equals this. What step did we take in order to do that? That's what they did. And here they come over and they say, well, we use substitution. Well, substitution is one of our properties, right? Substitution. If n equals 11, then 4n equals 4 times 11. Well, what they did was they said, hey, here's the thing that they changed. We said 4 minus 3, and they substituted it on 1. Okay, so most of us, you are going, hey, that's just subtraction. Yes, but subtraction is not a property. subtraction is an operation. We need to know what property did you use in order to do that. Well, you did the subtraction, and then you took that one and you put it back in place of where you did that subtraction. That's substitution. Trust me, I know, when I first looked at it, I said the same thing you did, okay? It's okay, because it is substitution. They have equivalent values, so you substituted it in. That's what we're talking about here, okay? So we took 4 minus 3 and we substituted in 1. And then they rewrote the problem. And then they come down here to this next part and they said, okay, well, from here to here, what did we do? Well, 7, so we just have a 7 here now. So they said it's 7 times 1. Well, which property do we have? Well, we come back over here and we go, okay, well, what property did they use? Well, 7 times 1 is the multiplicative identity. Any number times 1 gets you back that same number, right? So 7 times 1 gets me back 7. That's the multiplicative identity. 7 times 1 equals 7. Okay, and then they finished writing it out. Then they took the next step, and this is called proof. It's a proof. So we're saying, okay, this is how we did this problem. We're proving that it works. Okay? Then they said, right here, 7 minus 1 plus 1. Oh, wait. Well, we got rid of this 5 and this 1/5. Well, what did we do here? Well, 5 times 1/5. Oh, well, that's the multiplicative inverse, or the reciprocal of 5. So we did the multiplicative inverse. 5 times 1/5 equals 1. Therefore, this number is 1. That's what they're doing here, okay? So, and I'm going to make you do this, so you better be ready to do this. Then they did 7 minus 1 plus 1. Well, this is the same thing as what we did over here. We did the subtraction. But subtraction is not a property, so we need a property. So we substituted in the 6. So 7 minus 1 equals 6, so we substituted it in. 6 plus 1, added together, 7. Substitution, 6 plus 1 is the same as 7. This, if you don't know your properties, is going to be very difficult, okay? That's why I wrote this out like this, so that you'd have your properties, that you could look at them and go, what's the example I need? And what am I doing here that looks like what we have here, okay? So if you can follow these and have these written out, guys, write this down nice and cleanly so that you can use it, okay? And you'll be okay, right? And you're going to use all of these at different times throughout this stuff, okay? Here's what your problems are going to look like, some of them. And they're going to say, name the property used in each step. Or they may ask you to do the problem and explain the step that you used in order to do the problem. Okay? So 2 times 3 plus 4 times 2 minus 8. Well, they did 4 times 2. That got them 8. Multiplication, I believe that is substitution again, because those are equivalent. Okay, so substitution. Then they did 8 minus 8. Well, this is additive inverse.